All right, we're going to continue with oxidation and reduction. Section 21.3, how to identify an oxidation reduction reaction. We left off with 2 Mg plus O2 yields 2 MgO, and we looked at their oxidation states. That's how you tell. If they have a change in oxidation state, it's an oxidation reduction reaction. So again, we said magnesium was 0 because it's an atom. Oxygen is 0. Again, an atom, actually a molecule, but in its elemental state. And then in these compounds, this is a 2 plus and this is a 2 minus. So you can look at this and you can say magnesium went up in charge. Okay? Therefore, magnesium has been oxidized because its charge went up. And then you can look at oxygen. It went from 0 to -2. That means it has been reduced. Again, a short version of this is called what we call a redox reaction, short for oxidation reduction reaction. One can't happen without the other. If you look at the magnesium, it's losing, so where do those electrons go? Something has to pick them up, and that's your oxygen. Okay? So that's an oxidation reduction reaction. Again, you can tell because you have one that's being oxidized and one that is being reduced. Let's take a look at another reaction. We have carbon reacting with oxygen to produce carbon dioxide. Again, carbon is an element, so it's 0. Oxygen, elemental form, 0. Here, remember, oxygen is always a -2, unless it's a peroxide. Since there's 2 of these, that would give us a total of -4, which means our carbon has the apparent charge of a +4. So that's its oxidation state. So we can see carbon went from 0 to 4, so it was oxidized, where oxygen went from 0 to -2, so it was reduced. Okay, remember, to be reduced, you either completely gain or partially gain electrons. Here you completely lose or partially lose electrons. Now, there's another term that you need to be familiar with, and it is called the oxidizing agent. So oxidizing agent and the reducing agent. Your oxidizing agent is the substance that causes oxidation. And this would be the substance that causes reduction. So if we go back up here, if a substance is oxidized, that means it lost electrons. Those electrons had to be picked up by something else. So when this is oxidized, it causes oxygen to become reduced. So if it's oxidized, that makes it the reducing agent. Okay. Here, this is reduced, which means it gained. Well, if it gained the electrons, it caused the magnesium to become oxidized. So anything that's reduced would be the oxidizing agent. Again, you can't have one without the other. So as long as you can identify what's oxidized right away, you know that this is the reducing agent. This was reduced, therefore it's the oxidizing agent. Okay, so that is identifying by using oxidation numbers. Again, you have to have a change in its oxidation state for it to be a redox reaction. But there, remember, we learned a while back, we have 4 types of reactions. You have your combination or synthesis. We had our decomposition. We had single replacement, and we had double replacement. Now remember, double replacement always occurred when you had 2 aqueous solutions the ions switch places, and then it forms a precipitate or a gas or water. Okay? Because they're just switching places, their oxidation states do not change. So your double replacement is never a redox, ever. Okay? These three could be redox. So if you see a double replacement reaction, then you know for sure it is not a redox. And when I say could be, it's probably more a better term to say usually will be redox. All right, let's take a closer look at a harder one, because so far we've started with 0, and it's been easy to determine if it's going to be a redox reaction or not. Let's take a look at this one. 2KClO3 decomposes to 2KCl plus 3O2. So it is decomposition, so it should be a redox. Okay. But what I need you to do is identify the oxidizing agent, the reducing agent, what substance is being oxidized and which one is being reduced. So you're going to have to go through and you're going to have to check their charges. Potassium is in group 1. It's always a +1. Oxygen likes to be a -2. So the tricky one is going to be figuring out what the chlorine is going to be. So again, this was our rule number 2 from the other day. This was the rule number 4. Those are in your book if you need to go back and look at those. So here you've got 3 times 2 is going to be a -6, and you've got a +1. So that means your chlorine has to be a +5. Okay. You come over here, oxygen is 0. Right away I can see that oxygen is going through a change. So oxygen goes from a -2 to a 0. That's an increase. So that means that it's oxidized. As soon as I know it's oxidized, I know that it is the reducing agent. Okay? Now I just have to figure out which one is being reduced and therefore is the oxidizing agent. So I have to look at these. Again, potassium is +1, chlorine -1. Okay, again, going back to your rule 2s, those are your common ionic charges. So you can see potassium did not change, so it did not go through reduction or oxidation. However, your chlorine went from a +5 down to a -1. That means it is reduced and therefore is our oxidizing agent. It causes the oxygen to be oxidized. Okay, let's try one more. Let's react zinc with copper chloride to produce zinc chloride and copper. I'm going to start with my easier ones, my elements. Zinc is 0, copper is 0. Here chlorine's a -1. Since there's 2 of them, my copper is a +2. Come over here, my chlorine is a -1, my zinc is a +2. So my chlorine is not changing, so it's not oxidized or reduced. But I can see that my zinc is going from 0 to a +2. Okay, so that was oxidized. Therefore, it is the reducing agent. And then I can see copper is going from a +2 down to a 0. So that was reduced. That makes this the oxidizing agent. There are sample problems on your worksheets. There are sample problems in the book. If you look at page 610, 14 and 15 are practice problems, and 14 has the answers in the back of the book. If you have any questions on any of them, let me know, and we can always set up a Zoom meeting.